Hi everyone, I'm Vanto. Today, we are going to dive into one of the most fundamental and essential topics in computer science and programming. Array data structure. Arrays are everywhere in programming, and understanding them is key to building efficient software. Here is what we'll cover today. Let's start with the basics. What is an array? Array is a fundamental and linear data structure which is a collection of same-type elements that are stored at contiguous memory locations where the elements are identified or accessed by their indexes. That means, it stores elements one after another in a straight sequence. And all elements in an array are of the same type, for example, all integers, or all characters. And importantly, they are stored in contiguous memory locations, meaning, side by side in memory. Each element has an index, starting from 0, which makes accessing any element very easy. You can now view different arrays on the screen. Now, let's understand arrays with a simple real-world example. Imagine a row of school lockers. Each locker has a number, which represents the index. Each locker stores one item, just like each array cell stores one element. And since all lockers are placed next to each other, that's just like how arrays are stored in contiguous memory. If you know the locker number, you can directly open it, you don't need to check others. That's the same as accessing an array element using its index. Arrays come in different forms based on their dimensions. One-dimensional array, this is the simplest type, where elements are stored in a single sequence or a row, one after the other. Multi-dimensional array, this is a general term for arrays with more than one dimension. They are typically used to represent complex data in tabular form. Two-dimensional array, this can be viewed as an array of arrays or, more commonly, as a matrix containing rows and columns. Three-dimensional array, this extends the concept to three dimensions, like a cube of data or an array of two-dimensional arrays. The pattern continues for even higher dimensions. Let's demonstrate the different types graphically. One-dimensional array. A 1D array looks like a simple row of boxes. Stores elements in a straight line. And elements are accessed through indices. Notice they always start at 0. Two-dimensional array. A 2D array looks like a table or a matrix. And have two sets of indices. One for rows. And one for columns. You can access an element by specifying its row and column index. For example, the element at row 0, column 0 is 3, labeled a 0, 0. One of the best uses of 2D arrays in programming is the chess game, where the chessboard is represented as an 8x8 2D array. Three-dimensional array. A three-dimensional array takes it a step further, it's an array of 2D arrays. You know the 2D array. Think of it like a stack of multiple matrices. To access an element, you need three indices, one for the matrix layer, one for the row, and one for the column. A 3D array can be represented as either a cube or a cuboid. Now, let's see how the 3D array is displayed as a cube. We use 3D arrays for storing complex data, like RGB images or 3D coordinates. The syntax for creating arrays in Java typically involves specifying the data type and the size. For a 1D array, data type square brackets array name is equal to new data type square brackets size, semicolon. For a 2D array, data type square brackets array name is equal to new data type square brackets size 1, square brackets, size 2, semicolon. And for a 3D array, data type square brackets array name is equal to new data type square brackets size 1, square brackets, size 2, square brackets, size 3, semicolon. For an uninitialized array, you use new keyword. You can also initialize them directly. Int array name square brackets is equal to fleur brackets 1, 2, 3, semicolon. Char array name square brackets is equal to fleur brackets a, b, c, semicolon. Float array name square brackets is equal to fleur brackets 1.0f, 2.0f, 3.0f, semicolon. These are just different ways to create arrays depending on your need. Arrays have a few key characteristics. Random access. You can jump directly to any element using its index for extremely fast retrieval. Index always starts from 0. That means the first element is at index 0. Homogeneous data. All elements must be of the same type. Indexed access. Every element is given an index for direct access. Fixed size. Once created, you can't change its size. Contiguous memory. Elements are stored next to each other in memory for fast access. Default values. When an array is created, its elements are automatically initialized to a default value based on their data type. For example, in Java, an int array is filled with zeros and a Boolean array is filled with false. The most common and fundamental operations on arrays are: update, used to update an element in an array. Display, used to traverse through all the elements of an array and display them. Get, used to retrieve a value at a specific index. This is a very fast operation due to random access. Let's walk through a simple example. Step 1. Create an array. We declare an integer array of size 5. Now, an integer array ARR of size 5 is created. Initially, all elements are the default value, which is 0 for integers. Step 2. Insert elements. We insert values like ARR 0 is equal to 10, ARR 1 is equal to 20, and so on. Now the array stores numbers. Step 3. Update an element. We can update a value, like changing index 2 from 80 to 30 using syntax ARR 2 is equal to 30. Step 4. Retrieve an element. We can quickly retrieve a value. Asking for ARR 3 instantly gives us the value 40. It's that simple. Here is the basic algorithm for a one-dimensional array. Step 1. Start. Step 2. Input the size of the array. Step 3. Create an integer array of given size. Step 4. For each index I from 0 to size -1. Input the element and store it in array I. Step 5. To update an element. Before updating or retrieving an element, a critical step is checking if the provided index is valid. If index is valid, then array index is equal to value operation proceeds. If not, an index out of bounds message is displayed. Step 6. To get an element. If index is valid, then display array index. Else display index out of bounds. Step 7. To display all elements. You simply iterate through the array and print each value. Step 8. Stop. Now, the Java code shows how the algorithm is translated into an actual program. The one-dimensional array class manages the array. The constructor takes the size and then uses a scanner and a for loop to fill the array with user input. Methods like update and get include the essential index validation check, preventing common runtime errors. The display method uses a simple enhanced for loop to traverse and print every element. It lets the user create an array of any size. Update elements. Retrieve elements. Display the whole array. It also handles invalid inputs with messages like index out of bounds. I'm going to execute and explain how a one-dimensional array program works in Java. Let's go step by step through each operation, update, get, and display, to see how the array behaves in real time. This command runs our Java program. Once it starts, the program asks us to enter the size of the array. So here, I'll enter 5, which means I'm creating an array with 5 elements, from index 0 to 4. Now the program is asking me to enter elements for each index. So I'm entering 10, 20, 80, 40, and 50 respectively. After entering all the values, my array looks like this. Now the program shows the available operations. I'll select one, which is the update operation. So I'm entering index 2 and changing its value to 30. Previously, index 2 had 80, but after the update, the array becomes 10, 20, 30, 40, 50. Now I'll choose 2, which is the get operation, to retrieve a value from a specific index. The program asks for an index, and I'll enter 3. Let's see what's at index 3. This means the value stored at index 3 is 40, which matches our array perfectly. Now I'll select 3, which displays the entire array. And there we go. The array is displayed correctly after the update. Finally, I'll select 4, and the program ends gracefully by printing exiting the program. So overall, this program demonstrates how a one-dimensional array works in Java. You can create an array dynamically, update any element by index, retrieve specific values, and display the whole array at once. This is a simple yet powerful example to understand how one-dimensional arrays work in Java using loops, user input, and switch case statements. Arrays are useful when you know the number of elements in advance. Because arrays are fixed size, they are perfect when the data count is static. You need fast access to elements. If you frequently need to retrieve an element by its position, arrays are order 1 time complexity, which is the fastest possible. Data is homogeneous. You need efficient memory usage. You are doing frequent access but not frequent insertions or deletions. When you need to perform numerical computations. For numerical computations like matrix operations or vectors, where fast indexing is essential. When order matters, as the index inherently maintains the sequence of the data. Arrays are fundamental to computer science. Here are some of their applications. They are used to build other data structures like stacks, queues, hash tables, linked lists, array lists, heaps, trees, and graphs. In enterprise systems, database records are often implemented using arrays. They are also used for system tasks like lookup tables. They are heavily used in sorting and searching algorithms. In modern technology, machine learning datasets are typically stored and processed as multi-dimensional arrays or matrices. Even network buffers internally use arrays. Despite their speed, arrays have some significant limitations. The most critical limitation is that once a static array is created, you cannot change its size. If you need more space, you must create an entirely new, larger array and copy all the elements over. Can't store mixed data types. Inserting or deleting in the middle of a large array is inefficient because you have to shift all subsequent elements to maintain the contiguous structure. This is generally an order n operation, which means the time complexity grows linearly with the size of the array. Understanding complexity is key to efficient programming. Time complexity measures the time taken for an operation as a function of the input size n. The first operation is insertion, where you need to insert all the elements of an array of size n, which takes order n time complexity in all cases. Updating an element is always order 1, constant time. Accessing any element takes constant time, order 1. This is the great advantage of random access. That's why arrays are fast and efficient. Visiting every element is always order n, linear time. In the worst case, searching for an element might require checking every item, making it order n. Space complexity. The space required is simply order n, which is the space needed to store the n elements themselves. In Java, some common exceptions in arrays are array index out of bounds exception. This is the most common and occurs when you try to access an element using an index that is less than 0 or greater than or equal to the array size. For example, trying to access ARR 5 on an array of size 3 will throw this error. Null pointer exception. This happens if you try to use an array that hasn't been properly initialized or has been explicitly set to null. A restore exception. This occurs when you try to store a value of an incompatible type into an array. For example, trying to put an integer into an array declared to hold only string objects. That's all about arrays, from basics to implementation. You can also check the description for the PDF version of these notes. Thanks for watching.